the pandas, right? So we saw the NumPy yesterday. Similarly, pandas is kind of a library, which is the floss library, okay, which is floss one, that is your free library open source software, right? And it provides a high level performance for your data manipulation, analysis, wrangling, and whatever you want to do with your data structures, right? So this is your pandas. Okay, so for installing the pandas, you can just go with the install and you can just write pandas. But before that, you should mention your pip, or you can mention your conda over there, right? So that is not necessary if you're working with Jupyter notebooks. Okay, so there are data structures, right? So data structures are there in the pandas. We deal with some of the data structures because we are going to work with the data. So that is particularly called as some data structures, right? So three kind of data structures are there. Okay, there are three kind of data structures. Let me mention them. So your three kind of data structures are series, data frame, and the panels, right? You write it as the series, the data frames, and the panels. Okay, these are the three data structures we are having. Okay, so let me define this as, let's say this is data, and let's make a dictionary. Say this is, okay, this has been working here in the codes. So let's say this is my data structure, and there we have series, there we have data frames, there we have panel. Alright, so we have three of the kinds of this data there. Similarly, we have the dimensions of this. So this data structures, like of the series are dimension, the series are one dimension, the data frames are two dimension, and like then the panels are the three dimension. Okay, so just write a descriptive one so that you can remember it. So what I said, this series are nothing but the 1D labeled array. Alright, we deal with the array yesterday. So this series are nothing but the 1D labeled array. Similarly, this data frames, these data frames are nothing but the two-dimensional labeled array, and we call this as mutable arrays, right? And so does we have this as the three dimension. Now you would be wondering why I have written it in the kind of a dictionary, right? So these are your datas, right? There is some invalid syntax in the line number array. There might be some missing things. Okay. This is the missing one. Fine. So this is your data, and I have made some of the things, right? So you can just see your keys, you can just find out your values and like that, right? You can just find out your values over this, and you'll come to see keys as the data structures, dimensions, and the description, and their values to be the series and all these things, right? So these are the values and the basic one, right? So this data structure contains of series, data frames, and panels, as I said. So panels are nothing but the 3D dimension, or you can say 3D labeled arrays, right? Now, for like the numpy, we imported this numpy as import numpy as np. Similarly, here for the pandas, we'll import this pandas as pd. That is important, first of all. Okay. So import pandas as PD. Now we'll discuss it. We'll discuss one by one all the things, that is series and data frames, because these are much of the things to be used in. Okay. So we'll use one by one. So what are series? So if we go with the definition, series, as you can see, is nothing but a one-dimensional array like structure with homogeneous data, right? So if you write it as, so I'll say that series are a one-dimensional array like structure with homogeneous data. Alright, with homogeneous data, right? Like a numpy one dimension array, like this one numpy one. So for example, you can say, as let's say we did yesterday, that is import your numpy as np, and let's just say that this is an array 1, 2, 3, 4, and let it be anything. So this is a one dimension array, and that is your series, right? We can call this as a series. Okay, so we can perform many operations on this series, and we can just check it on how it works on, right? So we'll performing one by thing in the series. Okay. So when working with the data and when working with the series, before working with the pandas, let me tell you that how can you check your version to your pandas. So you just have to write as pd dot underscore underscore the versions, and that is enough to get your versions, right? Okay. Now we'll try to make series, we'll try to manipulate on the series, we'll go for the queries, the deletions, and all those things, right? So first of all, we'll try to create a series from a list. Okay, so let's say this is a number, and this is a number list, and this is some having some numbers, let's say 10, 20, 30, 40, and let's say 50. Okay, this is the number I'm having, and I want now the series. So the syntax would be that you will be writing your data first, whatever your data is, and then you will be writing down the index and the data type. Understood? So what is your syntax? Let me just give it as. So always you will be starting with capital S, and you would write it as first the data what you want, and then you can just pass on this index values and the columns, or sorry, not columns, the data type what you want. Okay, this is how you can write the syntax of writing a series. So we have number with us. Okay, now I'll just write it as similar in the above statement. So I want series and my data is the number. My index, I haven't defined anything. Okay, I'm not defining anything now, let it be as it is. We'll define in the next one. Okay, so this is data equals to number, and then I'm just running this, and you can see this, that this series whatever has been generated is 10, 20, 30, 40 and 50, and this 0, 1, 2, 3, 4 are nothing but the index values of this 10 to 50. Alright, and you are getting a data type by default is kind of an integer of 64 bits, right? That's okay. So if you go for the for checking the item size, so what will that? That will be 8. We read yesterday, right? Okay. Now let's say I'm making this series with the same data, but assigning some index values. So we have 5. You can say 5 of the numbers. So I'll assign it as, let's say 6, 7, 8, 9, and 10. And I'll also assign the data type now, and I'll say this to be an float value. So you can see now that this 10, 20, 30, 40 and 50 is having some float, or the values of float 64, and the index values to be from the 6, 7, 8, 9 and 10, right? This is how we use the series from a list. Similarly, we can make a series from any, you can say, dictionary, or we can make a series from any numpy arrange. Let me show you. So let's say that I'm making a series with a numpy arrange, or numpy particularly. So this is now array, and I say this to be 1, 4, 16, 25 and 36. Something is missing. 9 has been installed. Okay, so these are just an array over there, right? And now let me write the index to be np dot range, and let this to be from the 2 to the length of there is no such length, so let's say 1 to 6. Okay, and data type is understood, right? So what you can see is we are having a series of some 1.0, 4.0 and some values with some of the index values. So I made this index to be an range of 1 to 5 numbers, and I am getting that I made this array to be 1 to 25 there, and this data type has to be float. Now we have a dictionary called as data, right? We have a dictionary called as data. So let's make a series with that. So we'll write this as data is equals to data, right? Itself data is there. And meanwhile, you can index your values. You don't need to write anything when you are creating with a dictionary. You just run this and you will be getting your data structure to be series, data frames and panels, your dimensions to be 1, 2, 3, your description to be this kind of thing, right? And then you can check on the data type to be object. So what you have got that if you write an integer, you will be getting an int 64. If you write a float value, you will be, if you're writing a float, you will be getting some float values over there. And if you write a string over there, you will be getting an object. Alright. So this is how it works on. Similarly, you can make things from your, you can say tuples and like this, right? You can make on the series with any of the followings. Like for the whatever we have did, like the sets, right? Now you can find the index value of any series just by writing the series name and then dot the index, and you will be getting the index of that. Suppose this is an series, and I just assign this as an x. So this is your x, right? But if I check on the index values of x, so the index values of x is data structure, dimensions, and the descriptions. Similarly, I can find out what is the values of x. So these are the values of x. Okay, so you can check it on and you can write like this. Okay, fine. Similarly, let's say this R1 to be random of some 5 numbers, and this R2 to be a random of again 5 values. Okay, so we'll be taking some R1 and R2. It's good, and we'll make one OR. Let's say int is also there, or and that to be range of the length of this R1. That's okay. So the range will be coming 5. So let's see, OR is okay. 1, 2, 3, 4, 5 plus 1 would be fine. So this is 1, 2, 3, 4, 5, and let's see R1. So that is having some 5 numbers, and what about R2? This is again having some of the 5 numbers, right? So this is your this kind of data, right? This is your some random values over there, and what we'll do is we'll generate two of these series. So we'll say this as series 1, series 2, and we'll write this as pd dot series of our data to be given as R1 and index values to be OR. Similarly, be writing more series over there. We'll need this data to be R2. This index values to be OR. So we'll just see our data now. S1. This is our S1, and like that. Okay, before printing S2, let's see. So this is your S1, right? You're having your index values from 1 to 5, and you're having your numbers over there. Now you can index out the values, like let's say S1 of 3. So we're getting S1 of 3, that is this, right? 1.3 and something values over there. You can just more index on things to reverse out your byte into, right, the simple slicing and the things we saw yesterday too also. So we can pass on this to that is how you can get the values. So you can just write on things to get it to understand, right? So this is just an indexing method. Similarly, I can just pass on this S2 to print out there, and this is your S2, right? Okay. Now, what I mean to say that we can perform some operations on this string, on this series, just by adding them up, right? We can perform this by subtracting from them. We can also perform some multiplications on them, right? We can do these things. Similarly, we can append any values or not. So we can use this appendations or not. We can just write add any values or not in the series. So we can add, let's say this S2. So OR to be 6 and this random S2 OR length of one to length of OR plus 1. Length of index passes implies 5. Okay. So 1 to 7. This is your S1. S of 3. This values will be changed up now. So we can just write on this as S1 plus S2, S minus 1 and all these things. Now what I mean to say is that you can find out the differences from this operation. When I started, we are getting some NaN over here. This NaN states that these are nothing but some null values, or you can say it's no values are there right on, okay? So that is called NaN, right? So it is 5, it is having some 6 elements, it is having some 5 of the elements, right? So there is no 6 element here, so it cannot add anything with this. So this is a NaN value over there, right? Meanwhile, you can just index on these things, right? Let's say 2 and let's say this of S2 of 2, you can add on those things, right? So these are the operations you can perform with a string, right? You can, let's say you want to drop this 6th position. So what you will do is, you'll be just using this drop S2 drop. You will write 6 that is the sixth position will be dropped down, right? So like this, you can manipulate your series. You can just do anything. You can just use it as a add functions to add on the values, and you can write like you can do that. Okay. So there is subtraction, multiplication, division, and like things of that. Yeah. For getting a statistical description of these data, what you can do is you can pass on the median, you can pass on this mean to find out things, right? So like let's say you pass on s1 dot max comma s1 dot mean, sorry, mean s1 dot minimum, that you can pass on to get some of the values. Even if you can pass on s1 dot median, so you can see your values by passing these things, and it's you getting all the data, right? So what you understood that you can work with the series, you can just make anything there, right? You can also create an empty series. Just if you don't write any of the things, you'll be getting an empty series. Okay. So you can make a lot of things with the series, as you can see, right? So we can retrieve data using the labels. You can retrieve the data using the indexings. You can find the sum and all these things. You can also find the sum of this S1, and you'll be getting the sum, right? So this is all about the series. Now we'll come to deal with the data frames, right? So if we call data frames, so what exactly are data frames? So data frames are, you can say, like a mixture or like a collection of some 2D data, 2D array, or you can say as a tabular form, or you can say a table of rows and columns. Okay, that is exactly 2D structures, right? So now let's start with the data frames. Alright, so syntax is again same. You can write on here what are the syntax here. If you just write, so here you can write as pd dot data frames, and that is how you can write first your data, and then you can write your index values, then you can write your columns, you can write your data type, you can write a next column, and that's it, right, of things, right? You can pass on these things to get up there, right? So these are your data type. These are your data frames, you can say, right? So let's make a small data frame. Okay, we have made one data frame with the help of this dictionary. You have seen this. We have this data as our dictionary. So what we'll do, we'll try to make a data frame from this. So I can just write this df equals, or you can just print out that this is pd dot data frame, and that is data here is my data. Okay, and just run this. So you can see this data structure, dimensions, and the description over there. So what we made, that series is one dimension and is having 1D labeled array that are mutable. The data frames are two dimensions and having 2D labeled array, and you can see, right, this is one side and this is one side. You are getting a 2D label, right? This is a label one, this is a labeled one. That is how you write. So let's make one more data. So let's say this to be countries, and let's say this to be Belgium, we can take India, we can take Brazil. Okay, and let's take all the capital. From this we can take on Brussels. We can take this New Delhi. Is it Brazil? Capitals Brazil. Population is around 9046. this is going to let's say any particular values to be there, right? Not much. Okay, so this is a kind of dictionary again. I'm saying this as df, and that is data frame, and this is I'm writing it as data frame, and let's say this data and columns. Define the column names to be this country, capital, and this population. So even if you don't define, that is not an issue. You will be getting that because this is a dictionary. But still, I'm just giving you an overview of how you can define it. So this is kind of populations and all those things, right? And at last, you can just print your data to see how it looks. So this is how your data will look like, right? You can just also pass on this EF to look better. So this is your country, and some things are there. Equate this. Who is this? Add me. Okay, so there has been a small error. Let's connect this. Capital. That's good. I can see this there. So nothing named, no minister. It is not from any of the batches. Okay, so we found this to be a dictionary of like that, right? So I must show you how this dictionary works well, because there we have one data. Let me show you. So there we have one of the data, that is like this. Okay, so that is having some these are the real time data, right? We have taken from this website, and that is Indian players batting average values or ranges, you can say, right? So this is a dictionary particularly. So we have player, their span, the matches, innings, and all those things, right? So how a dictionary plays an important role, you can see, like let's say if I make a data frame of this, so you could see that is your batting, bat underscore average underscore Indian underscore players. So this is bat underscore average underscore Indian underscore players. So what you can find, this is a tabular data what we have made with this help of a dictionary. Okay, so this is whole made with only of the dictionary what you can see here. Okay, so now see, this is a good data, right? We are having around 20 to 23 columns. Okay, that including the zero, it's 23 columns, and we are having some of the that's 23 rows, and this some columns are there. So you'll get into it later onwards. Okay, now first of all, let's see. Whenever you deal with the data, so your first work always is to be get the information of your data. So to get the information, let's say I'm writing it as, So to get the information about your data, what you do is you just print your data name and you print the info. So you'll be getting the info of that. Okay, so DF is my data where I'm having country, capital, and the population. So I'm getting this is like that. Okay, that is using some 200 bytes of storage only. Okay, so the range index is 3 entries. I'm having some 2 columns. So that is your index value 0 to 2 and some columns of 3, right? So, and to get a statistical output, you can say, or statistical info of your data, you can pass on this as describe. So that will give a statistical output, that is population, counts, means, and all this. So you'll not get a good one in this one. Okay, you're not getting a good description of that. So let me name it as crick, and let me just run this. Okay, that is now crick. Okay, so what you can do is, let me show you. So we saw when we just print on this crick, what we saw that some 22 data has been printed at a time, right? So we don't want to see everything from this. What we'll do is we will try to find out the first 5 or first 10 or whatever. I just want to see a glance of this data, right? So what I'll do, basically what I'll do is I'm going to print out the head of that, right? So we'll write it as head. So this head will print the first 5 rows of your data so that you can get an understanding of what are the starting numbers, what are the starting things which are included in your data. So you can see some 5 of the values. So for getting the first 5 rows, you can just write on this crick and dot head and you can get it over there, right? Similarly, you can write on this tail and you can get this last 5 values, right? So this can be used with this. Now, if you want to make a particular column of any of this column, let's say average or HS or runs or anything. So if you want to make a particular column as a series, because many a time you could be asked to make a column as a series, how to represent a column as a series. So to make a column as a series, you will just have to pass on the, you can say their data name, and then you just give it indexing and write this here, the column name. Let's say I'm writing span. So I will get here a list of span there, right? So again, that depends how much you want. You want up to first 5 or like that, right? Once again. So that depends how you want first 5 or how much, right? So you can write it as, and you can get your spannings, and like you can represent anything in the series. So what you are saying that this is a 1D array and this is the name of the series and this is the data type of that, right? So you can just take on the name also, you can, okay? Similarly, if you want to just get only the first one or only the first row, not to get out all these things. So what you can write as this script dot head, and you can pass on this 1, and that is your data, right? Similarly, you can go with the tails too. So that is a general overview with the info, that is general statistical with the describe. Okay. So to find the number of columns in your data frame, what you will do is, that is columns, and you will get it as these are your columns. So to find the index values, so there you will be writing as index and then the values. Sorry. So these are the index values, you can get it. Okay. Similarly, you can get your column values too, right? You can just write that as crick dot column dot values, and let's say I'm only getting the first 5. So there's right. So like this, you can get your column values. But so there is some errors. So let's say you just write the columns, or you can just pass on the values. Let's see, you will get in their values of its first 5. So you can get the values, right? So that is how you get things over there. Alright. So you can even pass to see that if any null values you understand that any blank spaces are left in your data or not. Hmm? So you can pass it in the null values also to see whether these things lies in there or not. Like okay, so you can write it as, let's say, your crick is having any null values, and if it is there, I just want to see the head. So I can see all the false because this data is not having any null values. So there you can see that these are nothing but the no null values or false are there, right? So that is how you can see this is null values, it's containing or not. So to see whether this is not containing any null values, we'll just write as crick dot not null, not full, it's null. And again you can see the let's say now we'll see the tail of that. So you can see that there are true values. Now true values state that there is no null values. Okay, this I'm finding not null, so I'm getting true values over there, right? If I write a false over there, then that states that this is having some null values. Okay, this is false particularly, right? So we can even see some of that, right? Let's say if you want to see a sum of this is null, so we can write it as sum, and we can found that whether any null values are there in this or not. So I'm getting that no null values are there, right? You can even find this as not null, and you can even find the sum of this. So you're getting that every particular column is having some 23 values, right? That is the number of rows we are having and exactly the number of columns. So you can even check out with this graph, plotting with this graph. So you can just like write this thing. So for plotting a graph, what we can do is we'll be working with C1. We'll be starting this, don't worry, not today, tomorrow might be. So we can just plot a heat map over there. So we can just plot a heat map and say this is crick dot is null, and let's say the C map to be now there are C map states that it can be different kind of palette or different kind of designs we can say, alright. Suppose let's if I say this as ASN, so this could be something different. So this will give you a plotting of that, and you can get it like this, right? What this says that this blue color is stating that this is 0. Now 0 means that there is no null values. Okay, so higher the color will be, the higher or the true values will be there, right? So this state at this 0 and this is nothing but there is no null values, right? You can now you can change your palettes and you can get anything, right? Let's say I'm writing blues, so I'll be getting it something different, right? That is how again this color states that this is a 0 or there is no null values over there. Now you can write many things, right? Let's say blues and underscore r, and you'll be getting something different. So that is a reverse color of that blue, right? So there are a lot of things you can pass on, like there are grids, that is one. So there are almost around some more than 100 of palettes to work on. It depends on which one is of your choice. You can write a winter, then you can. So my favorite is an orange one. So I use particularly this. So I use oranges, OR, and this looks like this. Okay, so that is good. Okay. So this can be used as like, okay. Then you can slice on the things on your data frame to work on. Like you can slice. So to get a specific column or to find some range of columns, what you'll do. So for getting a specific column, you can write, let's say, crick or crick, and then you can write some two brackets because you need to find some particular columns. So let's say I want to find this player, I want to find this uh, only the matches, I want to see only the strike rates and the runs. Okay, I want to see only these things. So this is also a lot of coming there. So let's say only the head of the data. That is the first five things I want to see. And second, see this M.A. Agarwal. I think it's Mayank. Okay, so having 11 matches, strike rate of 55.97 and scoring some 974 runs, right? Similarly, there is Bumrah or Ashwin. Okay, Ashwin has scored a good one. That's nice. 71 matches, some runs, and strike rate is also good. Similarly, so you can get on your data to find out. Let's say we want it from that tail. So what is there? Hmm. So it says that is so how to find that who is having the maximum number of runs scored, right? So runs is having some integer value, right? So what you can do is you can just find out that runs is equals to, you can say this to be as crick of runs, right? You can say this as crick of runs, and then you can see what is the runs dot, what is the max value of this runs, and that is 7240, right? That is 7240. So you can find out that again with the indexing values. I'll telling you how you can find out that those things. You can find out those things, right? You can just use IDX MAX, and you can find out the values over there. So no attributes of max. Okay, fine. That is okay. So integer is not having any max values over here. You just need to find it by the locating it as, right? So you can just write it as there are various ways. So these are not in integer because it might be an integer, so I can find it out. So I'll dealing with those things. Don't worry. So I see that this is in 7240, right? So if you pass on those things or previous things, what we can see that this is having some. If you write it as, so this says that this is having 7240, right? So let me see this runs and let me see this true value. Let me see this. This equals to 7240. So we can just pass on the type of runs and we can see on what is this. So we found that this is a panda goes runs over there, right? So can we do it as np dot, can we write this runs to be a array? Can we write this? So can we say this as an array? And can we now find it with the use of where, what we did yesterday? So can we find that where this runs value is getting 7240? So it's saying in the sixth position rather than sixth index value. So in the sixth index, this value is coming to be 7240. So can we not print this? Can we print this of six, right? To print out a particular row, to print only a particular row, what you can do is, can we do like this correct of sixth? So same columns, okay. So this is your sixth, you can say on sixth row, okay. So this is of particular Virat Kohli, and we can find the number of runs to be 7240. That's exactly correct, okay. So there are ways of finding many things, right? So this is the number of matches and 86, strike rate of 57. That's good, and that is you can find, okay. So to get specific rows, so this was an indexing with the help, this was a method of finding the number of rows with the help of an index location. So we know the index location, that is 6, so we use with this, okay. If we don't know the index location, we can just find out using the location method, right? So that can be used to find out the things. Let's say I want to print the sixth number, I want to print the seventh or eighth, so I'll be getting the 6, 7 and 8 as ratio, right? So you can find these things there as, okay. So this is particularly the row index value, or you can say as row slicings, okay. Now we'll try to see how to add any columns to our data, right? So we are having a df, that is your country data. Remember, this is your country data. So let's say I am saying this country, I'm adding a country code. I'm saying this to be okay. Let's say it's having 32. This is plus 9 1, and this is plus 5 5, and then I can see my DF, and then I can see a one more column as this country code, right? So I don't need this actually because this is well enough to be there, right? So what you can do is you can even delete this particular column. So but for deleting, you can just write DF and then you can pass your thing there, right? So that will delete the data and you can see your previous data again. So similarly, you can even index the location of your data. You can just find out using, let's say, if I'm writing df.iloc, and that is ilocate location, you can say. So let's say I'm finding the first 0 and then 0. So this states that I want to find the index location of 0 of 0. So 0 of 0 is nothing but Belgium, right? If I run this, so you can see 0 of 0 is the nothing but the Belgium over there. So that is how you can get your values. Okay. So to find the number of or to slice over the rows, you can say. So there you can just write it as, let's say, df of 0 to 2. So there you can just slice things. That is, you only want the first two numbers or first two rows over there too. Okay. They can write like this things and you can get it over. Okay. So to add anything in the rows or to add, so to add a row in your data frame, we saw how we can add a column over there. So to add a row in your data frame, there is a method called as append, right? There is a method called as append and you can add it like that. So let's say if I copy this data, if I just change some things there. So let this countries to be Japan and Russia, and let this capitals to be Tokyo and Moscow. Let the populations to be 14.45 crores. And this is having 12.6. Okay. So now df1 to be the data frame of this. You can find your data like this, right? Having some values over there, and you can even find out your event. You can find, say, your index to be 1 or 2. That is, or let's say this to be 3 or 4. Invalid index, right? That is 3 and 4. We are getting your index values, and right. So now our main goal is to add on this 3 4 with this 0 1 2. Okay. So what we can do is we can write new data, that is df2, and that would be a df dot append the values of df1, right? And then we can check on this df2 and it will be like 0 1 2 3 4 and it's having some data, right? So this is you can how add on the number of rows in your data. Then even if you can generate the, if you focus on that now, if you just get, if you just you find to see the real times data, if you just focus on to find out the real time data there. So you can find out to how to generate a random numbers and how to just make, so how this things works on how this number of random data which is generated every day in Google's, right? How this thing work there. So there how they work. Let's say any random numbers is to be taken over there. Let's say this is random and this is yeah. Let's say this to be a 5. So if I see my RANDN, RAN, so I'm having some 5 numbers, right? This is how RAN works actually. So let's say we are going to import random and this code to be there. Now I'm going to do some of the operations. So range of some nice. So let's do it random. Okay, these are the numbers. Let's say this code to append those values of x, and let's say this to be g. Str of x, right? So if I take x, that would be a misconception there. So let's do it. C. That would be nice. So done. I think that is good. So I can just print the code of the first 50, and we can find out some of the Google codes over there, right? We can find out the things over there. So there are the codes. Now to make these codes as a tabular sheet or as to be printed in any tab, or let's say to make this, how can I make this data store in my hard disk as an Excel sheet, okay, as an spreadsheet, as an CSV file or an HTML file? How can I make this data to be there, right? So what I can do is I will use some of the techniques to be there, right? So I can use some of techniques. Before using that, let me make you you can say like for the date range, let me make you compatible with the date range, right? So what are actually the date ranges? So date range are nothing but having some ranges of dates, right? So if you write it as dates, and let me write it as pd dot date range, okay. And if I say this to be today's date, let's say 2020, this is today 8 first, 2nd August. 2nd August, 8 2. That's good. And we'll see the periods. And I'm saying this periods to be 10. And why I'm doing so, I'll let you know why I'm doing so, right? So I'm saying this periods to be 10 now. So if I just print on my dates, I can see this to be having some dates over there. It is 2 from today's date until the 10th, right? That is 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And this is your frequency, that is your dates over there. And the data types to be date time of 64 bits, right? Exactly. So these are the dates. Now, why I have made this is actually, let me show you why. So if I want to make a data frame of some random numbers or random generated data, like we have generated this random one 5, okay, we have generated this 5. So like if we have any random data over there, so how we can make these things, right? How we can just make some random inputs, or we can say random data. So let's say just say this random to be 100, or let's say this to be, we have 10, right? So let's say this to be 100, okay. and then we'll reshape this to 10 cross 10. 10 cross 10, and let's see, this random, this is having some 10 cross 10 data, that's good. Okay, now we'll try to make a data frame where we'll give our data to be random, and we'll say that is our index values, that is our index values should be now the dates. Okay, and the columns should be, let's say, this should be the columns. Yes. Okay. So you can see some random generated data, that is your RANDN and what you got there, right? So these are the dates as per the index values, and this A, B, C, D, E, and this as the columns, right? So I have used split method. That split method basically what does this? This will make this in a list, right? So if you check your columns, you will be having this as a list of some. Now it will not define by, because you are having your data in these columns, right? So yeah, you have not made any variable, you have just assigned the value this to be a. So if you just write on these things as AB, let me say this, if I write AB and if I write S split, so you'll be getting a list of this individual numbers exactly, right? So that is your data frame. Now I'll be doing the same thing with this Google codes. How will I save these things? So this is my X. This is my you can say codes over there, and I'm having this data. Right? Now, what I'll do is I'll say these are codes, and my codes to be an array of the code what we have done, that is your our code. Okay, so that is codes will be an array of codes, and I will reshape this, and since this is a 10,000 codes, so I'll say this to be 1,000 by 10, so 1,000 rows by 10 columns, right? Nice. So 1,000 by 10 would be fine, and then I'll say that these are nothing but the Google codes, and I'll save this as data frames. It's not there. I'll say my data to be the codes, and I'll say this columns to be dates. That's nice. Okay. So if we just run this, no problems. So if we just see our G codes info or G codes head, what you can see is the number of Google codes generated per day here, or like number of codes in generated in months. Let's say today is 8, so how many codes generated today? So how you can see that how many codes have been generated today? So you can see that your G codes 2028 and this 2. So you can write it as, and then you can check for the values of this, and this will give you the number of codes that is generated only of today. Okay. So you can see like that number of codes you have been generated in this particular day. Similarly, you can pass on these things to see for rest of the days, right? So like for the 3rd August or 4th August or 5th August, or like you can see this number to be very large, right? So I have only generated some only of some thousand, right? Some thousand rows. Okay, so that is your data coming there, right? So let's see the first 5 values. So these are the first 5 values. So similarly, we can just pass on these things as, let's say, let's make it. So even if we can pass on these things to write it as, let's say, to be the codes of you can see on the length of it's having and there is some thousand numbers, right? That's exactly because when you see your index values, if you see G codes dot the index values, so you can find. Sorry, that would be the values. So these are the values of the index. Say that these are the index values, right? Because this is having some from 0 to 999, right? So let's give it a score 5. Okay, so these are the things you can just write on. Now this was the first. Now this was all clear about how what are data frames, what are series, how we can work on this series, how we can work with the data frames, how we can select on some of the particular data, how you can make your own random data, right? And also what you can do is you can convert this data to some different formats. Now that is called as some input or output operations on the on the data frames, right? So if you want to just make your data output to your data frame or like in the Excel sheet or CSV format, right? So what you will have to do is, let's say I'm saying this G codes dot to underscore CSV, and let's say this to be G codes dot CSV. Okay. So I'm making this as CSV1. So let's say G underscore CSV equals to CSV file. So that will be converted in a CSV file, right? Similarly, I can do it as G underscore HTML, and you can write these things and you can just save on these things. Now it will be stored in your the drive what you have by default, what the positions you are having. So it is saying that we will be having this in the IBM sessions. So we are having CSV. If we just download these things, we'll be seeing how it works. So this is your HTML. If you click on this, you can see an HTML just overview of this 10, right? So we can see is the number of codes generated on 22 August, 3 August, 4, and then like for that, right? We haven't given any of the time, so we are not getting any times over there, right? So it depends on how you write. So these are nothing. Some of the thousand codes over there you can see on some random generated data, and these are some of the thousand codes. So it is around some 10,000 exactly because we are having some 999 codes over there in one particular row. So there will be some of the codes, right? Then that is an HTML file. You can just make it or like a random one, right? Similarly, you will be having some. If I say this 1 second. So if we just check on for the downloads, today's downloads, that is the files. Open with this Excel. So this is you can see that this is stored in your Excel sheet, and you can check on these things for the first two to your 10 or 11 like things, and you will be having some 999 rows there too, like this, right? That is 999, and there you can see all these things. Now this might be having some unique values or non-unique values. They might be having some of the repetitions in this whole data, right? So then it could be possible that they might be having some random or like duplicate values in this. So that is not much of our issue to work on. Okay. So our work was just to make some random data to get and see how this works. Okay. Now, okay. So you can just convert anything from any of the topics, or you can you can convert in JSON or any PDF or like in different formats are there to work in. Now you can read the data from the you can say You can read the data from, if you have any CSV files, you can read out the data from there and you can just see all the things. Right? How? Let me give an overview of that. So if I say to see most of the operations on this, let's say I'm having you can say CSV file or XF file. Even if you don't have, you can just bring it from internet and you can just write it there. So let's say I'm bringing from this internet. So for that you need to be having some cbound over there, and you can write it as, so I'm loading some iris data, and that can be written as sns dot load dataset. So even if you don't have this data in your PC, you'll be getting there. So down there, you can just check it on this iris, and this iris is particularly a flower which is having some three species on set of the versicolor and versicolor, right? So even if you don't have data, you can write this command and you will be getting this there. But before writing this SNS, don't forget to write this one. Don't forget to write this, and then you can just run on this thing and that will be working and same, right? So this is iris data, okay, and you can grab these things from the internet easily. So that will automatically come in this section of that. So there are sepal lengths, there are sepal widths, petal length and petal width, and the right hand side you are seeing is nothing but the species. Okay. So this species are of three kinds. These are of setosa, these are of versicolor, these are of versinica, right? And you can just check on these things. Let's say I want to see the number of columns this iris is having. So that could be just seen as iris of columns. You can see the sepal length, sepal width, petal length, and petal width over there. You can just see the more for more. You can just see the info of this, and that would be much better if you see the info. So that says that sepal width is having some 150 non-null values, say for the petal width and sepal width and all those are having some of the non-null values, and that's good, right? Because these are having some exactly everything is having some values over there, right? So that's good. Okay. So you can just even check it like iris is null. You can plot a map of that again. So that's interesting to plot a map to see. So this is, let's say this time I'll be using THX. So I can see that this data is not a null one, right? That is not good. Let's take something different. So this is looking good, right? Look at pretty, like a female color, right? So let's see if I could manage to see something different. That is also not good. So this could be fine. That is good. Okay. So we are having rainbow, right? You can just write down the rockets and the things on. So this is not a null value. I can see it there, right? Now we'll try to see the number of occurrence of things over there, right? So we have been seeing that there are some of the values. So how many species are there exactly? Okay. So to see on, so we are combining pandas with the cbound here. Okay, I'm combining the pandas and the cbound in one of the contents. So how many species are there to find out? How can you write that? You can just write on to find the number of species to be. It is iris dot the this particular your this is species, I think S capital or it might be small. You can write L species and you can see some 150 values. So there are not 150 species. There are some. I said that there are only 3 species, right? So there are not 150 species. So how we can find that? So that is again the method. That is your. This is your NP array, right? So you can apply here unique, and you will get this. This having only 3 kind of species: Setosa, versicolor, and virginica. Now with this data, I can get the info that there are 150 values of. So how many there are Setosa? How many values of Setosa? How many values of virginica? How many values of versicolor are there? Right. So to find them, we'll have to do some sort of codings. So what we can do is we can say this iris, and we can pass on this species, and we'll check now where the values are coming as Setosa. We are checking for the Setosa. So where the values are coming to be Setosa. So I'll be getting a true false things out there, right? So these are some of the true results. So what I'll do is I'll make a list of this, and I'll just count the true values. So I get the 50 Setosa values are there. Okay, like similar we can just check on for this number of versicolor. And that is also 50. So if these are 50, the another one will also be obviously 50, because we are having only 3 of the species, 2 are 100 and the rest will be also 50, right? So even you can just see it without just writing on the things. That will this is why we see the plottings. That will make our work easy. So what we can do is you can just write SNS dot one count plot is there. So we can just count plot, and we can just give this, we want to plot this species, and our data is iris. So we'll get that there are 50 Setosa values, there are 50 versicolor, and there are 50 virginica. That's good, right? So you can write on these things. You can even use the C maps there. It is working here. Let's check. If it works here, that's good. Yeah, it's not working. No problem. You can use palette. If it is working or not. So there has been some changes basically. No need to. Okay, fine. So this is your 50 Setosas, 50 versicolor, and 50 virginica, right? That is cool. Okay. Now you can even plot a graph between the petal width and petal. You can say petal length and the petal width, right? You have petal length and petal width. So you can plot the graph between the petal width and the petal length. How? You can say this. You want some scatter plotting. You want some scatter plot, and your data is petal width, and your y is petal length, and you say your data to be this. So sorry, there is one A missing. Petal width is not defined. That's to be defined there. So this is your graph of the petal width versus. Now that is pretty messy there, right? So what we'll do, we'll try to find this on the basis of the species. That's good, man. Okay. So I've written a hue semantic. Hue semantic is nothing but a kind of a labeling which will make you understand, which will make you like, which will make you clear to understand that how this graph has been, or will make you give an idea of this particular label, right? So you can see setosa, you can see versicolor, you can see virginica, right? So we use these things, this particular data set is used in this machine learning process because we use this data set because in machine learning we have some of the types as clustering, we have uh, linear regression, we have some logistic regressions to find on this thing, right? So we use these things in the linear machine learning. There we can find for while clustering. So clustering is particularly a method there where you make groups of your data, right? You make individual groups of your similar data. So this is, you can see versicolor is here. This is virginica. So you can see this setosa can be easily classified between or from these two things, right? It is having some separate category from this, right? You can even if you are from a biological background, you can find these graphs in your books, right? So this is you can get anywhere. So in machine learning, we just plot some like if you do with the linear regression, this model can be built with linear regression too. So if you want to see just a regression plotting of this, so you can even write sns.reg plot, and then you can just write on your data. So you can see argument is missing. Let's see this. So you can just plot on your so here you can see this regression line. So this particularly stands that how many, what is the best fit line you are getting to train on your models. So we try to make these things closer here to find the best fit line to just make it things. You can see this as, I can make this large for you. Big size. Let's say to be a 10 cross 10. Keyword can't be an expression. So there you can see that is not good enough. So what you can see is still it is not clear. Let's make it as 10 cross 8. So here what you can see is this, these are nothing but some of the data points you can see, right? So these are the data points which are just coming closer to this. So what we do there is nothing but we try to make a best fit line where the number of errors, these points could be managed in one particular line to be everything, right? So we try to make those things in this machine learning parts. Okay, we are not much into that. So there you can see the number of types, right? Similarly, we have a data of crick, right? You have your data of crick. So let me recall this to you. You have this data. Now to see which, apart from that index location, now to only see that which player has scored the maximum number of runs. What you can do is you can use the method called as sort the values, right? So you can sort out the values according to your according to your requirements. Right? So you can just write on the script and you can sort the values as, so that is sort by, and you can sort this values. So you can use the sort values also. The sort values, and you will be writing by what. So if you want to sort by runs, and you want to see some head of that. So it is saying that these are the values sorted by run. So see, sorting always happens as the values of ascending order, ascending in an ascending order always. Right? So that is I write it as. So if I write this ascending order to be false, okay, always you will be seeing us in an ascending order. That is always your values to be always your values be in the least two grades. Okay. So if I write this ascending order to be false, so I can see a descending order, right? I'll be seeing a descending order. So if I write crick.sort values by runs and write ascending or false, what you can see is the highest number of runs, and then you can see this difference, like that is your seeing, you can see that the what do you can say is that is descending on, right? And you can see the index values changing. That is first is 6, and then for 12, 13. So it sorts according to the runs, and nothing else has been sorted out. Everything will be as it is. Only these things, the runs will be sorted, and nothing else, right? So this is how you can sort your values. You can sort by any number of things. Let's say you are sorting your values by the person who has hit more number of 6. So you can just write it as the more number of 6. I think it from the Rohit Sharma. I hope it would be Rohit. Yeah. So it is Rohit there. So having 52 sixes here, right? Nice. Number of 4s is also greater. How many matches he played? This was a test match. This is a test match data. So 42 matches. Good. And this is like how you sort out the values. Right? Okay. So similarly, you can just index out some of the values. You can make it description. If you see a description of this one, that will be much good. If you just see a describe of this, so that will give you a good one. That you will get a every row is having some. Most probably, every row is having some integer and float. So you will be getting a good statistics data. It is count stands for the number of data you are having. This innings, and then STD stands for the standard deviation. This mean for minimum values, max, and 75-50% over there. Right? This is how you can locate the things. So you can try on the things, you can write on the things, and then you can do these things. Right? So meanwhile, you can import the data to right, if you have any data in your you can say in your hard disk, so you can import those things. Let's say this is my, let me upload any CSV over there. So it's this bank details CSV. One second, hold on, I'm coming. Yeah, so this is particularly the data which I am going to import is created by a girl, right? She has made it as her internship project, right? So that can be a random data. Okay, so let's say this is bank. So bank details are there, so PD. So for importing a data, guys, you will have to write it as pd dot read, and whatever the format you are reading, let it be a CSV, let it be an HTML, right? So I'm using CSV, and the data name is, I think, bank details dot CSV. I think it's so. Let me check it. It's bank hyphen details dot CSV. Fine. So bank details CSV. Nice. So let's see her data. So she's having 29 out there. Okay, that's grade 1. So let's see the info first. So she's having some 30 entries, alright, and some columns 10, okay. Account number, PIN, name, branch number, phone number, email ID, age, address, balance. Good. Okay. So no null values again, that's good. Object are 5, integers are 5, equal ratios, memory uses. So let's see the head of this data and get to understand more. So account number is there, PIN is there, name are there, branch names, branch number 4, phone numbers, email ID, age, balance, and like this. So you are asked now, let's say you have a data of this bank, and you are asked to find out who is having the most number of balance now. Who is having, so by the end of the month, which person is having the most number of balance in his account? So that can be a good question. So how you say that? So that person will be only the balance so this is the person who is having the maximum number of balance by the end of the month. Okay, that is, I will sorting the values and I will find only the one. Okay, the only one, and he's having around he's having 92 lakhs, 96 lakhs in his account. Correctly. Yeah, he's having 96 lakhs. That's great. I should contact him, right? It's a girl or a boy. Okay, she's a female, I think. So you can contact on this number there. Okay. So this is like the most number of balance having by the end of the month. So how to get the least number of balance, right? So again, you can just pass on these things. Or who is the most aged person in the bank? You can just check it out. Like this, write it as age. I think it's age over there. Age, yes. So you can pass on this AGE. So the aged, let's say now we are trying to find the younger one. So the youngest is this 20 years old boy, I think. Branch name Mahalakshmi account, good. And this is his data, right? So you can find out the things. So how many email ID a bank is having? If a user is trying to log in, how you can get his login credentials to him? I can give his login credentials. I can let him inside his bank and his load and let him know his numbers and all those things. I can give that data. So for that, what you will do is you will be doing some procedures, right? Yeah. Okay, so you'll be doing some of the procedures over there. How? That is interesting, right? Let's say I want to find the number of email ID I'm having in my bank on this data, or how many customers, what are the email ID of the customers I'm having. Okay, so will be this customer email, and that will be a list. Okay, and that will be a, let's say, set. Okay. So this is set. Similarly, let's take password or let's take the pin, and pin could be same or not. Pin might be same. I think it could be, might be same. Let's take it as this. Account number will not be same. So let's make this as also a account number. Fine. Name it as custom email is not defined. Oh yeah, exactly. So let's make this first. Alright. So see, yeah, this is not defined now. That's right, exactly. So what will be my customer's email? Let's say only this email. What will be the email of the customers? That will be the BD. I think it has been as email underscore ID. Let's go to email underscore ID dot values. First, let's remove this as things. Okay, let's first remove these things. I just say this is email. Let's see email. So that is good. These much emails are there. Nice. So let's convert this to be an list. And then done. So we'll see our email now. These are the emails. Nice. Similarly, we'll go with the passwords. So with the password, we'll go with the same things. Copy, create passwords, say to be a list, oh sorry, this to be a pin. Say this as BD, this to be a pin, and dot the values. This pin to be a set of pin, and this pin are let's say this to be a list of pin, because pin might be same. Okay, pin is fine. Similarly, we'll take for the account number. So that is how actually I gave someone to make a project on bank system, right? So she make it like this, and that is exactly correct method. So account info and then the values in there is account always must be a set. Nice. So we are having some account numbers, we are having email number, emails, and their pin over there, right? So that is correct. Now, let's say we'll make a small program from this data, and we'll try to see the real world issues. Okay. So let's say our user is coming for login there. Print like welcome to SBI, like anything, right? SBI India. Okay, so we'll try to take the ATM, right? Let's say this is an ATM. and what he'll do is he'll write his account number and he'll insert his account number, right? So we don't have any options to insert it. So we'll take his account number and we'll now write his PIN over there to access the contents, right? So let's say his account number will be input, enter your account number, right? So ACNO is enter your account number. Like if I say, if this ACNO lies in the lies in this email, sorry, lies in this ACN. So if this account number lies in that account, that's, you can say that in my database, right? So if the user account number is lying in my database, then I'll say to enter the password. Sorry, enter the PIN. So that would be enter PIN. And if this PIN lies in the PIN we are having, so if it lies within this, so if this happens here, we'll just print login successful. Okay. But if it is not same, we'll print on invalid PIN, right? Similarly, here what we can do is we can print email do not find, our email is not registered with us. Like the email is not registered enough. So for that I see some email numbers or account numbers over there. So let's say this account number is AC1042, AC1042. Okay, find experience 1537. So it's asking for the PIN. The PIN is 1537 with 1537. Oh, that is an invalid PIN. There's one there. Why it is an invalid? Might be the PIN is found in PIN. AC1042 1537. So actually it was a integer format and I was checking it with the str formats, so that would be problematic. So I converted this in. Now what you can do, even also what you can do is you can say that you can say to the user, right? You can say to the user that see you might have some issues if you're having some login invalid attempt. So you can just pass on these things. If it is PIN is invalid, you can just try to find this data over there. You can make a dictionary of this, right? You can make a dictionary of like, let's say, this is a small data I'm making. This is having account number as, this is AC info. Similarly, this is the pin I'm having. There is pin and the email is this email. That's nice. So I'll have to do one particular thing because this set might could not create this. So I'll have to remove this. Let it be as this it is. I have to do these things. So that could be a list one, pin one, and account numbers. We are list of ACL. So now alright. So looking good. Okay. So if I see a data frame on this, where it is. That's good. So you can see we generated a data of this particular one. We can also generate this by just by indexing the values, right? We can also generate this same thing just by using some methods of this account number, this branch name, and this email ID, just by writing these things. Okay. So let me stop your videos.